Okay, chapter 5 on systems. And remember, we had 3 different methods we could solve a systems problem. We could graph both of the lines, find the intersection, and that would be our solution. And we could use the substitution method and the elimination method. All right, so number 1 says solve the following systems of equations graphically on the set of axes below and state the coordinates of the solution. So we're fortunate that both of them are already in slope-intercept form, which is the preferable. Okay, sorry, I was interrupted. Okay, they are in slope-intercept form, which is the preferred form for graphing. Coefficient of x is your slope. The constant is your y-intercept when it's in slope-intercept form. So my y-intercept on this equation is 2. My slope is negative 1 over 3. So I can go down 1 to the right 3. Or I can go up 1 and to the left 3. And I keep doing this till I get to the edge of my graph, because I don't know where the other line's going to intersect. So I'll just connect my dots. All right, on the second equation, the y-intercept is negative 5. And my slope is 2, or 2 over 1. So I'm going to go up 2 to the right 1, up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. And you can just keep carrying that out, or you can go down 2 to the left 1. Okay. And we'll see that our 2 lines intersect where x is 3 and y is 1. So the solution for this is 3, 1. Okay. All right, number 2. All right, this also says to solve by graphing. And this time we only got one of them in slope-intercept form. So let's go ahead and get this one, put it in slope-intercept form by isolating the variable y. So we're going to subtract x from both sides to move it. And then we're going to divide by the coefficient of y, negative 4. And we divide everything by negative 4. For some reason my pen's not wanting to cooperate. So this cancels and we're left with 1y equals, and I always like to put my slope in front. So negative divided by negative would be positive 1/4 x. And then negative 20 divided by negative 4 is positive 5. Okay, so now going back to our graph, let's graph the 2 equations. So on the first one, my y-intercept's negative 2. Slope is negative 3 over 2. So go down 3 to the right 2. Down 3 to the right 2. Or you can do the reverse and do up 3 and to the left 2. Okay. So now we have our line for this equation. All right, for this equation, my y-intercept is 5. And my slope is 1 over 4, so I'm going to go up 1 to the left 4. To the right 4. Up 1 to the right 4. Then I can do the opposite, go down 1 to the left 4, down 1 to the left 4. So now my line's here. And if we notice, we are intersecting our 2 lines at negative 4, 4. So that's my solution. My x is -4 and my y is 4. Okay. Number 3, it says determine if the following systems of equations has no solutions, infinitely many solutions, or exactly one. All right, and we said that if they have the same slope but different y-intercepts, then that means they're parallel lines, right? And parallel lines never intersect, so that's no solution. If they have the same slope and same intercept, that means they're the same line. So it's just one big, huge line, because it's like laying another one on top of it. They have the same points as each other, so they would have infinite solutions. And then if they have different slopes, then it's one solution. Okay? All right, so we need to look at the slopes for this line. Now, somebody says, well, it's 5 and -5. No, this is in standard form. You can't get the slope from standard form. You need to put them in slope-intercept, so we need to isolate the variable y. So we're going to bring the 5x over, doing the opposite. And then we're going to divide by everything by 6. So we're going to get y equals -5 over 6x plus 4 over 6 reduces to 2 over 3. Okay, and then if we do this one, we'll bring the -5x over and add it. We're doing the opposite because we had to do that to get rid of it, right? And then we're dividing by the coefficient of y for each term. So we're going to get y equals 5 divided by -5 is -1x. And -5 divided by -5 is +1. All right? So for this equation, my slope is -5, 6. For this one, my slope is -1. So they have different slopes altogether, right? So they're going to have one solution. We'll have an intersection when we graph those lines. All right, but you definitely need to remember the different rules. If it's the same line, then there's infinite. If they're parallel, there's no solution. If it's anything other than that, then it's one solution. Okay. All right, the next one says solve the systems of equation. Doesn't tell us which method to use, so I'm going to do what I prefer. I like the elimination. So I'm like, okay, I got 8x here and -x here. So if I multiply this by 8, then I can cancel out my x's. And that's your choice. You can say, well, I could do the x's or the y's. But looking further, what if I add those together? What do I get? 0. So they cancel out automatically. So instead of doing 8, I'm just going to get rid of my y. Because if I add this together, -1x plus 8x is 7x. 2y minus 2y, they cancel out. Bring down your equal sign. -15 plus -20 is -35. So x equals -5. Okay, so now I'm not done. I need my solution, which is an x and y coordinate, right? So I only have the x. I can substitute -5 for an x in either one of the equations. It doesn't matter. I'm going to pick the first one. And this says -x, so it's -5. So it means 5. Well, let me show you. It's -x, so -5 plus 2y equals -15. So this is 5 plus 2y equals -15. So 2y equals -20, because all we're doing is solving for y now. So y is -10, x is -5, and there's your answer. Pardon, my sinuses are crazy. All right, number 5, it's the same thing. It says find the system, so we're going to look, can I clear out my x's? No, I'm going to have to do something. Can I clear out my y's? No, I'd have to do something. I'm going to pick my y's, though, because I can just multiply this by 3, and I get -9y, which would cancel those out. So if I distribute, I'm going to get 30x minus 9y equals 3. So I replace that with this. Now I'm going to add them together. -9x plus 30x is 21x. 9 plus -9 cancels out. Equals 18 plus 3 is 21. So x equals 1. Don't forget to get your y. So I'm going to substitute x with 1 and solve for y. So it'll be 9y. This would be -9, so I'm going to come over here and add 9. So 27, so y equals 3. So my solution is 1, 3. All right, number 6, it says solve the system using elimination, which is what we were doing. So we've got a -9x here. So I'm just going to do 9x here and they'll cancel out. Or I could have just done 8 here and they'd cancel out. But I'm just going to multiply this by 9. So 9x plus 9y equals 90. So now if I add those together, that cancels. And I have y equals 1. Okay, and then I'm going to plug it into 1 into this y. So x equals 9. So my solution is 9, 1. Number 7, it says solve by substitution. So whenever your y's, your variable's isolated, substitution is the easier method to use, because this is y is -6x. So I'm going to take this and substitute it for y. So -6x equals -4x plus 4. Bring my -4x over and add it. So I have -2x equals 4. X equals -2. Don't forget to solve for y. So I'm going to substitute -2 for x. So y equals 12. So my solution is -2, 12. Okay. This one says substitution as well, and we've got a variable by itself. So we're just going to substitute that y in the other equation with -3x. So -9x minus 2 times, we're substituting y, with negative 3x. And just finish the equation out. So negative 9x, negative 2 times negative 3x is positive 6x. Excuse me, y'all. Equals negative 12. Combine your like terms. They're on the same side, so you don't have to do the opposite. You're just combining like terms. So negative 3x equals negative 12. X equals positive 4. All right, so now find y. So we'll use that equation. Y equals negative 3x. Replace x with 4. So y equals negative 12. Solution is 4, negative 12. Remember, this is the point where these two lines would intersect if you graph them. All right, number 9. Okay, on this problem, all we're doing is setting up the equation. We're not going to solve them. We're just setting it up. So it says Aisha is a high school basketball player. In a particular game, she made some 2-point shots and some 3-point shots. Alicia scored a total of 14 points and made twice as many 2-point shots as 3 points. Write a system of equations that could be used to determine the number of 2-point shots Aisha made and the number of 3-point shots. Define the variables that you use to write. Oh God, y'all, I'm so sorry. It's very important to find your variables first. All right, so we're going to let x be the number of 2-point shots. Okay, I'm sorry, my pen doesn't want to work. And we're going to let y be the 3-point shots, the number of 3-point shots. Okay, so they said that she made a total of 14 points. So if she had her 2-point shots plus her 3-point shots, she had, oops, sorry, it's not value, is it? So for each 2-point, because this says total points, well, a 2-point shot's worth 2 points. So 2 times the number of shots plus 3-point shots. So 3 times the number of shots she had equals a total of 14 points. The other information they said was twice as many 2 points as 3 points. Okay, so our 2 points equals twice as many of the 3 points. Okay, so that would be how you set up. They didn't want us to solve it, they just want us to set it up. All right, let's look at number 10. Aubrey has 70 cents worth of pennies and nickels. She has a total of 22 pennies and nickels, so 22 coins. Determine the number of pennies and the number of nickels. And we can see that last sentence is determine the number of pennies and the number of nickels. That's your variables, y'all. So we're going to let x equal the number of pennies. Okay, this is what we're trying to find, our unknown. And y is your number of nickels. And she said she had 22 coins altogether, so we can say x plus y equals 22. Now value, our total value was 70 cents, right? So we know that this x and y represent the number of coins, so we have to multiply it by the value. So how much is a penny worth? 0.01, okay, for each penny, and then 5 cents for every nickel. So there's our setup. There's our two equations. So we can do elimination or substitution. And since I've got all these decimals, I'm probably just going to do substitution. So I'm going to get this variable by itself. So I'm going to plug in 0.01 x plus 0.05. And instead of y, I'm going to use 22 minus x equals 0.70, 70 cents. All right, so we're going to go ahead and bring this down, and then we're going to distribute. So 5 cents times 22 is 1.1, so $1.10, minus 0.05x equals 0.70. So now we need to combine our like terms. We're just adding them together. They're on the same side. Do not do the opposite. So 0.101 minus 0.05 is going to give you negative 0.04. Oops, don't forget that. Let me write that better. Negative 0.04 x plus 1.1 equals 0.70. So I'm going to add 4 cents. So you're going to get, oops, it's my coefficient of x, right? I'm not adding. I'm going to subtract $1.10. So I get negative 0.04 x equals negative 0.40. This is 0.40, and this is 0.04. Then we're going to divide by negative 0.04 on both sides. Make sure you keep your decimals right. So x equals positive 10. A lot of decimals there. All right, so I'm going to go back up here, and I'm going to plug in 10 for x. So y equals 22 minus 10. So y equals 12. So y is the number of nickels. So she had 12 nickels, and she had 10 pennies. Okay. This is why it's so important to write this down, so that when you get through, you know what is what, okay? You can identify it. I also threw in a couple of questions from the Chapter 4 test, just to keep you on your toes. Use point slope form to write the equation of a line that passes through the point 15, negative 20, with a slope of 3. So it said just use point slope form. So that's the only form we're looking for. So it's y minus y1. So y minus negative 20 would be the opposite, plus 20, right? Equals your slope, which is 3, times x minus x1. So x minus 15. Okay, that's your answer. You didn't have to do anything else. That's all it wanted. And remember, it's y minus y1 equals m x minus x1. And when you're plugging in, substituting these values for x1 and y1, because the formula has that minus in there, it's always going to be the opposite of these values. So if you notice, the negative 20 was plus 20 here. the 15 was minus 15 here. Okay, so make sure you get the signs right. There was a few of you who on that last test were not taking into account these minuses. Okay, so it's always the opposite of what's in your point. All right, and the last one, number 12, says write the equation of a line. So we're looking at y equals mx plus b of the line that passes through these 2 points. All right, put your answer in fully simplified point-slope form unless it's vertical. All right, so first thing, okay, sorry y'all, had a little disturbance there. All right, well, let me see if they're coming back. Okay, never mind. All right, put your answer in fully simplified point-slope form. So they want your answer in point-slope form. Okay. All right, so I need to know what my slope is. So I'm going to use my slope formula, which is y2 minus y1 over x2 minus x1. Your change in your y, your change over your x, rise over run, okay? So 3 minus 3 over negative 4 minus 6. Some of y'all should be going, ooh, ooh, ooh. Little red flag going off. 3 minus 3 is 0. And then that's negative 10. 0 divided by anything is 0. All right. What type of line has a 0 slope? Horizontal, right? Okay. Horizontal lines. Which axis do they cross? They cross a y-axis, don't they? So our equation is going to be y equals whatever my y coordinates are. That's why we have 0, because they're the same, okay? If my x's were the same, it would be a vertical line going through the x-axis. And it'd be x equals. Okay. And I want to kind of, while I've got you, I just want to kind of prove that to you. If I go ahead and put that in point-slope form, y minus 3 equals, my slope is 0 times x minus negative 4, so plus 4. So y minus 3 equals 0 times anything is 0. Isolate my y, and I get y equals 3. How about that? All right. So the test will be like this. Won't be the same numbers, but it'll be the same type of problems and 12 questions. Make sure you review, y'all, okay? I want to see all A's on these tests. All right. Y'all have a good evening.